O6C, omega 6. This is something that we should be able to calculate because we can measure the distance and we have the angular velocity is given. I look at C again and I see there's a prismatic joint there, so I need to be a little bit careful. I need to say this is C on length 6. Because there's a prismatic joint there, I notice that the prismatic joint is between bodies 4 and 5. And between 5 and 6 is a revolute joint. So I want the path of that revolute joint on length 4. I'm trying to kind of skip over 5. So the path, come on. The path of the pin, P5 or P6, on length 4, is this line right here. It's a straight line. Well, prismatic joint means an equation. So we're going to write an equation, step 2. Now I said we're going to get in the habit of using this on the left-hand side, the velocity of C6. That should have been C if they're not B.
Yeah.
Velocity of C6 is equal to the velocity of C4 plus the velocity of C6 relative to C4. What do I know about the directions? I know everything about this one from the first step. The velocity of C4 perpendicular to the line connecting it to the center of rotation. Center of rotation of length 4 is here. So I know the direction, not the magnitude, because I don't know the angular velocity of length 4. The relative velocity of a prismatic joint is tangent to the path. Tangent to a straight line is a straight line. So I know that direction. I don't know its magnitude. Now I know O4 and I know C4, and the rest of the mechanism is connected at B. So what do we do then? We know 2 points on a link. We want to get a third image. We want to have an image. Image of those 2 points I know plus the one I want to get to. I saw images, but I saw very few images that went to these. I was getting images that were going up to the corner or something else. These 3 are on the same body. So in my game plan, step 3 should have been image of 4, body 4, which has 3 points on it I'm interested in, O4, C4, and B. To get B. Okay, so I want that. Then I have another equation I need to write. Don't need to write one at B because it's a revolute joint at the same velocity, but I need to get to A. So 4. The velocity of A is equal to the velocity of B plus the velocity of A with respect to B. I know everything about B from the previous step. A relative to B is perpendicular to the line segment AB. And the velocity of A tangent to its path is going to be parallel to the ground there. So this says I have everything I need. All I need to do is to do the diagram. So we're going to pull my ruler out. I'm going to measure the length of OC measuring 31, but we have a scale factor of 1/2 up here. So that means I need to double it. So I'm going to put 62. Now that I'm thinking about the scale factor, I'm going to measure the length from 04 to C, looks like 30.5, so 61. I don't measure the second and third sides of the image, and I'm going to measure AB. If I do it all at one time, I see 32, so this is going to be 64. Got checked. Do all of those lengths that I have measured look about the same? Yeah, reasonably. If one was half or double the size, I forgot the scale factor, but when you measure them all at once, that's not likely to happen. So, let's see if I can get my game plan in over here. First of all, I have to have a vector C6. It's going to be perpendicular to the line segment 06C. Line 06C looks like it's horizontal, so the velocity is going to be vertical. It's rotating clockwise. So it's going to be vertically down. I'm going to get my triangles. So I have one side of my triangle lined up on that. I slide the other side of my triangle. Now I need a distance. I didn't calculate the distance, but now I can. I've measured it, 62 millimeters, and it's rotating at 0.9 radians per second. That's stated up here in the problem. And I didn't get my calculator up, so 62 times 0.9. It is about 56. It says 55.8. So I'm going to measure along that line 56 with a millimeter scale.
You did that
So I match it up, and 56 comes in right about here. I'm going to draw the line, and I'm going to label this point C6.
That's really fucked up.
Okay, so that's the velocity. Now I'm ready for the second step. The velocity of C4, absolute velocity of C4 is going to be perpendicular to the line connecting it to the center of rotation. It's an absolute velocity. So I come in here. Put one side of the triangle on that length. I know the relative velocity is perpendicular to that line. So I slide it over and draw the direction of the velocity of C4. I know that the direction of the relative velocity C6, C4, on my velocity polygon, it's going to go between C6 and C4. On my diagram, I can see C6, but I don't see C4. I know the relative velocity is tangent to the path. So I'm going to draw a line parallel, not perpendicular. We do a lot of perpendicular lines, but this is parallel to that path going through C6. And where those two intersect is right here. I'm going to make my lines a little heavier now.
By guessing.
And the last thing that I need to do for this step is to label C4. So C4 is right here. Now I see an image step. I see 3 points. O4, C4, and B. O4 and C4 are already on my diagram. Any fixed point is at the velocity pole. I don't need to label it O4. It's a stationary point. So one side of my triangle is this line that I've already drawn. The other two, we're going to draw lines perpendicular to the other two sides and make them go through the correct points. So perpendicular to CB, and it's going to go through C4 because we're talking body 4. And let me reorient these little.
No, you had it right the first time.
Okay, so I'm going to draw a line that's going to be perpendicular to CB. It's going to go through C4. And I can see that there's an obtuse angle greater than 90 degrees in here. So I picked the side that's going to give me an angle between the two sides I already have greater than 90 degrees. The last side that I don't have is going to be going through O4, which means it goes through the velocity pole, and it's going to go through B. So I draw that line in. Here's the intersection. What I need to do at the end of this step is label B. Here's B. One step to go. I can take either what's on the left-hand side or what's on the right-hand side. I'll take the velocity of A first because it looks pretty straightforward. The velocity of A is going to be parallel or along the tangent to the path. The path is going to be tangent to this constraint on the bottom. It's going to be an absolute velocity. So I'm going to draw that absolute velocity going through the velocity pole. Okay. One more thing. The velocity of A with respect to B. Well, it's going to be perpendicular to AB. Any 2 points on the same rigid length, the relative velocity is perpendicular to B. So I'm going to take AB, put one side of my triangle on that, slide the other side to where point B is, and extend it. Let's make my first line quite long enough. And that is going to be this line right here. The last thing I have to do is to label point A. velocity polygon. Questions? Looks easy when I do it, right?
Yeah.
Unfortunately. Because I've had practice after practice after practice, so. But the procedure, is there anything I said you didn't understand? Anything different radically from what I've been saying before? So, believe me, the only way you're going to learn this is practice. We haven't answered questions. So, we want the angular velocity of length 3, we want the angular velocity of length 4, and we want the velocity of A. I'm going to do the easy one, the velocity of A. The velocity of A is an absolute velocity, so it's the distance from the velocity pole to point A. I measure 86. I'm going to put it by my diagram. Maybe up here I'll put 85, round it to the nearest 5. And this is going to be millimeters per second. And it's generally in this direction. So notice I put generally and going up to the right. I can look at the actual diagram to know that if I put an arrowhead on this, that would be the exact direction of this goes. Velocity of A was pretty easy. The angular velocity of length 3. Length 3 doesn't have a fixed center of rotation. So I have to use a relative velocity between 2 points on length 3. I notice in my procedure I use the velocity of A relative to B. So I'm going to use the same thing. Velocity of A relative to B divided by the distance between them, AB. So I'm going to need to measure AB. I'm going to go down a little bit and solve for omega 4. On body 4 is really represented by my little image here. First of all, does that image look like the actual image on the mechanism, rotated 90 degrees and different size? It doesn't look unreasonable. So the first one that I got on that was C4. So I'm going to use the velocity of C4 divided by the distance O4C. Since it's an absolute velocity, I must have the distance from the stationary point to this point. So I only need to measure 2 velocities on here, so I'm going to go and measure both of those now. The velocity of AB looks pretty large. Looks to me, let's focus this again, like about 105 millimeters. And the velocity of C4 looks like about 39. So now I can take these numbers and put them into my equation. 105. The distance AB from up here, that's 64. The velocity of C, 39. O4C measured as 61. Get my calculator out, do the calculations. 105 divided by 64 equals 1.64. 39 divided by 61 is 0.639. So up here for omega 3, I'm going to put 1.6 radians per second, magnitude in units, and 0.6 radians per second. I need directions. So I'm going to draw an image of what's in the denominator here, AB. Here we go. B is up here, A is down here, just like on the mechanism. I'm going to draw a little image of O4C. That's up here. C is at the top, O4 is at the bottom. On this link, B is fixed because that's the second subscript, as if B was fixed. Down here, O is fixed. The velocity of A with respect to B starts at B, points towards A. Starts at B, points towards A. So I put it on the free end. The velocity of C4 is an absolute velocity. It's pointing kind of down to the right. If it isn't approximately perpendicular to the little sketch, that means you're using the wrong velocity. So this one is going this way, which happens to be counterclockwise. This one's going clockwise. So counterclockwise, clockwise.
So I have a question.
Yes.
Well, it's AB, since neither one of those were fixed, we used the second subscript, but because in O4C, one of those is fixed, it was the first one we used that because that one was fixed.
Remember last time we said that I could either choose the velocity of A with respect to B or B with respect to A and get the same answer? If I chose the velocity of B with respect to A, I would fix this A. And then the direction of the velocity, if it was B with respect to A, would have its tail at A. The tail was always at the second subscript and would point towards B. So if I had the revolute joint, well, here, let me just do it up here. And do the velocity of B with respect to A. I would have the same picture with A down here, B up here. The second subscript is the one we put the revolute joint on. The second subscript is where this vector starts. So it's pointing down to the left, which means clockwise. So notice we got the same direction no matter which way we had our relative velocity. Practice. I can go through a million of these in front of you and you're still not going to learn. I promise you. I've seen it happen.